What's up guys, welcome back to another video. Today I'll be showing you guys how to write a Python remote access Trojan script so you can basically get access through reverse shell to a Windows target specifically. This will work for Windows 10 and Windows 11 machines. So yeah, just stick to Windows 10 and Windows 11. I apologize I haven't made a video in a while. I've been really sick and really busy with work. But yeah, I apologize about that, but I wanted to make this video because a couple people were asking about Python scripts in my comments in one of my past videos, so I wanted to make a video about how to write hacking scripts. And yeah, let's just get right into the video. I'm gonna go over about pretty much every line of code in this video, not every single teeny tiny detail, but I'll explain what the code is doing and how it works. So we have a server side and we have a client side. I'm gonna write it with y'all, so I'm gonna go ahead and delete it. I have it saved on my second monitor, so I'm not doing it just through memory. So the server side is what will be on our attacker machine, and the client side will be on our target machine. So how we get the client side on the target machine, you just have to get creative. In this video, I'm obviously just manually putting it on my main machine, so I'm not doing anything special. But through a real hacking process, you basically fish someone, or you do it through an exploit to deliver the code. But yeah, you just have to get creative with trying to deliver the client side onto the target. But yeah, let's just get started. So the server side is the listener and the client side is on the target. So yeah, let's just go ahead and get started to the video. So the first two lines we're going to run are, and this is preference for these two parts. You don't have to do these, but Kali Linux, if you're using Kali Linux, it does this weird thing where when you run it, the program runs in the background and doesn't let you type anything, and it's because it has to be ran through a Python shell for the program to work. So you solve that by adding this line. And yeah, so just add this line. It's good practice to guarantee that works. So next thing we're going to do is add these two libraries, import socket and import threading. What these lines do, import socket is like the networking library for Python to manage networking, and then threading is so you can handle, in this example, so we can handle multiple clients at once. Next line we're going to define a function named handle client with the argument of client socket. We're going to create a infinite loop. We're going to try to get a command from the user. We're going to use a input so we can type in what command we want, and we're going to call it shell. Send the command to the Windows client. And if we want to exit the program and no longer have a connection, we're going to add this line. So cmd if lower. So if we type either one of these lines on the listener side, we will it'll basically just exit the program. That's what this line is for. And this line is to guarantee that the command gets encoded and sent back to the client, so we can receive a request. Now we're going to get the response back. And if there are any, we're going to add this line, so if there are any errors with the connection, it does not blow up or show a bunch of random output, we're going to get this line of code to make it to where it prints out an error so you can read it and understand what actually went wrong. Again, this is nothing super advanced. This is a very basic reverse shell in Python. And once the function is done, we're going to close the connection. So if either one of these lines break, any of these go through, it'll close the function, so it's no longer holding up. So we're going to define another function to keep the server actually running. So this line is right here is to basically receive back, output, and type in commands to send back to the client. This function right here called server loop actually keeps the connection open and running, and actually handles, actually gets the client to connect back. So we're going to define the circuit. We're going to create what's called a TCP connection, and I'll allow it to use our main IP address. So socket AF_INET, that means we're going to be using our IP address. And socket.sockstream means we're going to be using a TCP connection. A TCP connection allows us to guarantee like a full feedback connection. So it's kind of like when you send a message on a phone. When you send a message on the phone, it guarantees that's delivered by telling you that you deliver, like you know how you see the delivered sign under a message on like an iPhone or something. That's a TCP connection basically in a nutshell. And we're using this line for server.set socket. So I'm not going to get into the super tiny details of the script, but what this little line does, and this is probably a common issue you'll run into when creating your own Python scripts or any other kind of script with working with sockets and ports specifically. So it takes, once you use a certain port and you close the connection, it takes a few minutes for the machine to release the port so it's able to be used again. Typo there. But this line, what this does, it immediately releases the port so you're able to use it again right after. I'm not typing right today. I'm still sick, obviously. Now we're going to bind this IP address and this port. What the 000 is for is so we're able to listen to any IP address basically. The port 444 is just to show that we're listening to port 444, nothing crazy. If you wanted to listen to a specific IP address, you'd obviously type that specific IP address, but in this case, to make it really easy and not difficult, we're just going to make it to where it listens to any IP address. That would be so if we don't actually know the IP address if we're our target. Now we're going to create another infinite loop to accept our connection. So this is basically splitting the connection, so it creates a new socket or a network connection and grabs the IP address from the connection, the IP address and the port from the connection. So this is the actual network connection variable, and this is the IP address and port of the socket of the client that's currently connecting. We're going to print out that our client has successfully connected. We're going to allow our function we made earlier to handle the client that gets connected. So this is the connection from the client that we received, and we're using this function to send back commands to that specific client right there. That is what that's used for. So basically, if you're interested in what this line does, you use this basically on every executable Python script. It just allows the program to actually be run as a executable script, or running it through, like, say, Python 3. It allows all this code to get run through. That is what this line is for. It's the Python entry point. Name is like a special variable, and when the script is run directly, its value is main, so this code is ran. Now this next part isn't ideal. I don't really recommend doing this, but every time I try to do a Windows 10 virtual machine, it messes up and crashes. I don't know why. It's the most annoying thing in the world. So I'm just going to be using my host machine to use the reverse shell. Again, I know it's a super casual. I don't recommend this. Don't do this. Make your own Windows virtual machine for this. It's fine because this is my machine and I'm giving consent to it, all that stuff. But yeah, I'm just going to use a VM for this. Use like a VM for this. Don't do what I'm doing. It's just super annoying. But yeah, I'm just doing it for this video's sake. So I don't make it too complicated. But yeah, we're gonna be running the client script not on the Kali Linux machine. We're gonna be running it on our Windows machine, because this is basically where the file gets executed, so it goes back to our attacker machine, so we can send commands to it and all that jazz. So yeah, we're going to be doing some of the same stuff before. Again, I'm just gonna copy and paste it because I don't feel like typing it. Use that line again just in case. We're going to be importing a couple more libraries this time. Again, socket threading to handle multiple. We're going to be importing subprocess to run system commands. Almost typed what I said. We're going to be importing OS for operating system functions. Sorry, I'm looking at my notes and I'm looking back at the screen, so that's why I'm typing like a retard. We're going to be importing time. Forgot one. We're going to be importing sys for system specific functions. Is that 6? Yeah, okay, that's 6 libraries. Okay, we're good. Alright, so the first thing we're going to do is define a function called connect back. So, hence the name. This is allowing this machine to execute and connect back to our IP address. We're going to get this part in a minute. Don't worry about this. What? Okay, that's an ad for my phone. Get out of here. We'll get this part in a minute. I want to show you guys how to actually get your IP address. I'm not going to put my IP address yet, so don't worry about that part. I'll show you how to get that in a second. Actually, I'll just show you right now. Okay, so yeah, this is a mistake I made when starting out this video. So real quick, if you run ifconfig to get your IP address on your Kali machine, if it says something like 10.2 something is wrong. So what you gotta do is close your VirtualBox or Kali machine, whatever you're using. Go back to VirtualBox, go to settings, and go to network. I can't do it right now because I already have the machine open, but if it says NAT or anything else, change it to bridged adapter, and you should be able to get in a real IP address. Because what was happening earlier is that I was getting this IP address called 10.2, and I thought that was fine at first, but it wasn't working when I was trying to activate my reverse shell. It made it to where my Windows machine couldn't get a response from my Kali machine, but for some reason my Kali machine was able to ping in my Windows machine. So if you're run into that issue, just go into the network settings of VirtualBox and change it to bridged adapter, not NAT. So yeah, you should be fine for that. But oh yeah, let's go ahead and get the IP address. So you're going to be putting the IP address of your attacker machine onto your shell, and we're going to specify the port. So the port we used on the listener earlier was 444, so it's listening on port 444. We're going to print out a message to make it a little satisfying to look at. And we're going to create another infinite loop. We're going to try to connect back to the machine. So this attempts to So what this line does right here, it creates an infinite loop that attempts to connect. If the connection fails, it sleeps in our tires, but we create a TCP socket and try to connect back to the attacker's machine. So we got the client, this is TCP and connecting with that IP address and all, and client.connect is attempting to connect back to that server IP and port we specified earlier. And this is just a little message attempting it, saying that we got connected. What these ones are used for right here that I just typed up, it just gathers basic system information like the computer name, the username, the OS, the operating system that's getting used. It's obviously Windows, so I already put that. We send the information back to attacker so they know who they've connected to. Basically, that's what these ones are used for right here. So we add these ones to basically enter a loop that waits for commands from the attacker and receives up to 4096 bytes of data. We decode it from bytes to a string and remove any white space with the .strip function right here. And we add this one, so if we're not receiving any data at all, it breaks out of the loop. And we add this line right here in case we receive back exit or quit. We send back a message saying exiting. So that's just a break. Once on the server, if we type in exit or quit, it exits out, so, and sends that message. So we add these ones right here. These ones are basically used for handling the change CD, aka change. Dang, I can't talk. Sorry, I'm Walter White today in the flesh. My nose is all stopped up. But yeah, we use these lines right here. If the attacker, which is us, uses CD, it's going to run all this code because CD is a special command. Because it's not an executable program, it's built into the shell. So we handle it separately in Python's OS operating system library, which we added earlier, which is used to change the current directory. Yeah, so if you used a CD without this, it would probably send back an error, or it just wouldn't work. Or you might use it and it might not just change directories. That is one of the pitfalls I fell into when I first started writing this Trojan, that you need to use CD a specific way. that you need to create certain lines for the CD one exclusively. What these lines are used for, so if we aren't starting out with CD, it's going to call this else function, not a function like Python command, whatever you want to call it. And for regular commands, we use subprocess.popen to execute them. We use subprocess.pipe standard output and standard dir capture the command output, and we use the shell.true to run the commands in a Windows command shell, and we add text equals true to return output as strings instead of bytes. We use these commands right here to check if the command produced any output. If there's no output and no error, we send a message saying the command executed successfully. If there are any errors, we use this line to show what the error is back from the client. We send the command output back to the attacker and encode it with UTF-8 and converts the strings to bytes. If sending fails, we break out the loop with this line. This basically says if anything goes wrong, it's going to reattempt to trying to reconnect and wait 10 seconds before trying to reconnect, basically. I forgot to add this line right here. What this does is if there are any errors while connecting, it's going to print out the error. I spelled it wrong. I cannot spell today. Except, it says except. What? Okay. Okay, there we go. So it's going to catch the error as exception. It's going to print out the error. We're going to do exception is the error, but we put it into a variable called E. I don't know why I did that. Why is it doing this? Okay, there you go. Okay. And E is the variable. That will be the error in case there is an error. And once again, it's going to attempt to reconnect. Why is it doing this? Okay. It's going to attempt to reconnect in 10 seconds. There you go. And once again, yeah, this main function is just like it can use. It just allows the program to get executed once the file is opened. That's what these lines are used for, and these are the messages behind it. What this is for, which this is different actually. This allows the program to close. So say if you want to run this in the background instead of like being it open. Say if you fish someone, they download the file and try to execute. Say if they get a big screen with a black command prompt, they're going to get suspicious and try to close it. What this does is it calls the Windows API, the kernel, or just the API, whatever you want to call it, and closes the window automatically when the file is ran. So you don't see, so whoever runs it doesn't get suspicious and tries to close it. The only way they can still close it, it's not a rootkit or anything. They can close it within Task Manager, but it's unlikely they'll see it. And after this is done, it runs the connect back function, which we put earlier all the way back at the top. It runs this code. But yeah, that is the client side code. So we're going to run this on our Windows machine now. But yeah, now let's turn these files, well, turn this one file into an executable now, so we can run it and get a client, get it back in a connection to our machine. So first thing we're going to do is open up a new terminal and change the directory to where the code is. So now that you're in the terminal in the right directory, what we need to turn the file into an executable is type pip3 pyinstaller. You need this first. I already have it, so I don't need to run it technically, but I'll just run it for this video's sake. So you need to run this line to install that program. Now this is why you need to be in the directory for this part. I already converted it to an executable because I was testing it earlier. To turn this file into an executable, we're going to type pyinstaller one file. Then this part you don't have to, but it guarantees that the console doesn't open for the file. And we're going to type our program name. And we put the one file to guarantee it all gets converted into one file. So client.ret, now it's going to put into an executable now. So there you go. Now is in the dist folder as client._rat.exe. Next thing we got to do to make sure this works is to start the listener. So now we're going to run python server rat.py. You don't need to turn that one to an executable. You just need to turn the client to executable so it can run on your Windows machine. You don't need to, actually. You can run Python, but I think the executable one is more satisfying because it looks somewhat like a legitimate file. So now we're going to run the program on this machine, and on our host machine, aka our target. Now we're going to run client. Actually, let's do this as administrator just to guarantee it works. So alright, now we got a full reverse shell. So who am I? There we go. Windows host connected. This is the computer name. This is our user, my user at least. And yeah, it's showing the operating system as Windows. Now let's run ls. I think that's pwd. Yeah. So there are some errors still. But other than that, it still works. It looks like there's a bit of a delay, but other than that, it works pretty well. So yeah, you now have a full reverse shell. So let's try changing directories. But other than that, I'll give an update on the source code so it doesn't do this, but yeah. It looks like there's like a delay between the output. So yeah, but other than that, you can still change directories. So yeah. Alright, so you just need to type it a couple times for it to work, but other than that, it works. It looks like there's just a bit of a delay in between the output. You have to type it a couple times to get the output back. But yeah, now it's working. So yeah, it seems like a little delayed. I don't know what's going on, but yeah, I'll give it updated source code so you don't run into any issues like this. It looks like there's a delay within the output or something, but yeah, I'll give an update so you don't run into any issues like this. And I'll put comments in the code explaining what's going on. But other than that, it seems to be working pretty well. It's just a little delayed. But anyways, I hope y'all enjoyed the video and learned something from it. I will see y'all in the next one.